Okay. Good morning, everybody. So today we will discuss the lesson canonical and grand canonical ensembles. Canonical and grand canonical ensemble. So this is not important. This question. So first page number 44 and please open your textbook. Page number 44. Canonical ensemble. That question is you read that one. Only 5 marks question that only. Okay. Next one. Thermodynamic parameters using the grand canonical ensemble. Page number 49. Page number 49. Page number 49. Question number 7.6. Thermodynamic parameters using grand canonical ensemble. That question is also 5 marks question. That is not important to you prepare that only. Okay. This is I am not telling that one. So next page number 51. Page number 51. That parts you are observed that table comparison of ensembles. Comparison of ensemble. This is important. 5 marks questions sometimes given the your examinations time. So comparison of ensemble. That is tick mark. Okay. This block is only 5 marks questions came your exam. So 3 questions you are prepared that one. Next block 2. Block 2 quantum statistics. So here page number 58. Page number 58. Question number 8.2. Postulates of quantum statistical mechanics. This is important, very, very important question. 5 marks question only. Postulates. Postulates of quantum statistical this is 5 marks question, very, very important question. Sir, compulsory రావచ్చు question exam లో. Okay, postulates of quantum statistical mechanics. So this is all the system of nature of the quantum mechanics. Nature of the quantum mechanics. The quantum mechanics, the observable of a system is associated with the Hermitian operator. With the Hermitian operator. So with the operator, the Hilbert space. Which the operators on Hilbert space. Hilbert space. A state of the system, the vector, the state of the system, the state of the system, state of the system, the state of the system, modulus of J, modulus of J greater than modulus of the system greater than the J in the same Hilbert space. Hilbert space. This is the vector is the a system of the vector J of modulus of J greater than the Hilbert space at any instant of time. Here the any instant of time, the J of the wave function of isolated the system which can be what happened? Again, don't solve this. isolated system which can be expressed as a linear combination of a complete orthonormal a system of the the stationary states the stationary states the stationary state the stationary states wave function wave function wave function of wave function of phi bracket of phi I. So this is the stationary state wave function. So this is the state of the system is a J value. So J is equal to summation summation Cn phi of J Cn Cn phi of n r summation n Cn phi n Cn phi n. The Cn is the complex number. Cn is the complex number. No, don't sound please. Cn is a complex number. The generally here Cn is a complex number. The generally a function of time. The square modulus, modulus of Cn square. The square modulus, square modulus is equal to modulus of Cn square. So is the probability that the measurement performed the system will find the wave fund the will find the quantum number q is the operator in the expectation value at it of q is equal to j head of j pi sorry q minus of j by j into bracket of j is equal to summation 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 double summation cn cm cn cm cm into this to this is equal to phi n q q uh, qm qm by by only n and this is also n by summation cn comma cn cn. So here the postulates of quantum statistical mechanics are the postulates of quantum statistical mechanics are postulates of concerning the coefficient coefficient Cn, Cn, this value here. So Cn comma Cm whole bar, which here Q is equal to Q is equal to Q is equal to Q is equal to this value only. This is the Q is equal to this. You write this formula. So Q equal to this one double summation of Cn comma Cm whole bar into phi n Q phi n by summation Cn comma Cn. So the microscopic observation variable of the microscopic system in the thermodynamical equilibrium. In the thermodynamical equilibrium shown in the this is the two parts, also two parts. One is postulate of equal a priori probability. Second one is postulate of random space. Postulates of random space, that is two types. That is the two types. First one, that is the two types. Cn comma Cm, Cn comma Cm, Cn comma Cn whole bar is equal to 1 E less than E n less than E plus delta. E plus delta. That is equal to 0. 0 otherwise that. So second one is Cn comma Cn comma Cm whole bar is equal to whole bar is equal to a whole bar is equal to 0, that is n not equal to m. N not equal to m. That is n equal to m. This is also n equal to m. So that is the formula. Finally, your observation Q loss is equal to plus is equal to, that is here Bn value here is also totally is equal to summation Bn modulus of L square into this phi n comma Q comma phi n by this value summation Cn value is also Bn square modulus of Bn square. So here Bn square modulus of Bn square is equal to Cn comma Cm. This is a bar that is equal to sin. You say this one. Okay, this one. So this is only 5 marks question. Okay, so only 5 marks question. Very important question. 5 marks question. This one. Okay. So next one Page number 63. Page number 63. Three statistics only. 9.2 question number. Three statistics. That question you prepare that one. This is the three type of statistics. First one is Maxwell-Boltzmann statistics. Maxwell-Boltzmann statistics. Yesterday I am telling that one question is also fundamentals. So second one is Bose-Einstein statistics. Third one is Fermi-Dirac statistics. That is the question. This is a very important question. No? Maxwell-Boltzmann statistics. Second one, first one. Second one is Bose-Einstein statistics. Third one is Fermi-Dirac statistics. This is also very important question. 10 marks question. It's also 10 marks question. So that question you prepare, you read that one, Amma. Okay, only fundamentals that's one. So next to second question, the Bose-Einstein distribution function. Bose-Einstein distribution function. Next to question number page number 67. Fermi-Dirac statistics and distribution function. ఈ త్రీ క్వశ్చన్ లో 100% మీకు క్వశ్చన్ ఉంటుంది లాంగ్ క్వశ్చన్. ఈ త్రీ క్వశ్చన్స్ లో ఫస్ట్ వన్ ఈజ్ త్రీ స్టాటిస్టిక్స్ దట్ వన్. దానిలో వచ్చేసి త్రీ స్టాటిస్టిక్స్ అంటే మీరు మ్యాక్స్వెల్ బోల్ట్జ్మాన్ స్టాటిస్టిక్స్, బోస్ ఐన్స్టీన్ ప్లస్ ఫెర్మి డైరాక్ దట్ త్రీ క్వశ్చన్స్ రాయాలి. నెక్స్ట్ బోస్ ఐన్స్టీన్ డిస్ట్రిబ్యూషన్ ఫంక్షన్, సెకండ్ వన్ ఫెర్మి డైరాక్ స్టాటిస్టిక్స్ అండ్ డిస్ట్రిబ్యూషన్ ఫంక్షన్. ఈ త్రీ క్వశ్చన్ లో కంపల్సరీ లాంగ్ క్వశ్చన్ ఉంటుందండి మీకు ఎగ్జామ్ లో. 100% one question is compulsory it came. So I am telling this question first, the Bose-Einstein distribution function. Bose-Einstein distribution function. Distribution function. This is also 10 marks question. 10 marks question. So the system contain the n independent of identical particle, n independent the identical particle. Let the particle be divided into quantum groups. The level such that there are ni is equal to, for example, I is equal to 1 2 3 dash dash etc. So that is there are the ni particles in the group whose the constant energies are epsilon I is equal to 1 2 dash dash that one. Here ni is equal to n1 n2 n3 dash dash etc. ni. The occupation number of levels, that is occupation number of levels. There are gi is the single particle. This totally explained the yesterday class and is a concept. So let us the gi is single particle state in the level is the degeneracy, the statistical weight of the ith levels. It can be understood the energy level and degeneracy occupation numbers. Energy levels, this is energy levels is equal to sigma 1 sigma 2 dash dash sigma I. comma sigma k, sigma k, etc. dash dash. So degeneracy value, degeneracy value, degeneracy value is equal to G1, G2, G1 comma, G2 comma dash dash, Gi comma, Gi comma, G K dash dash. Next to occupation number, occupation number, occupation number is equal to, numbers is equal to which one? N1, N2, N1 comma, N2 comma dash dash, Ni comma, Nk, Nk dash dash. That is the value. So this is the energy level, degeneracy value, and occupation numbers as a value. So here Boltzmann-Einstein statistics. This is the Boltzmann-Einstein statistics. There are the restriction one of the particles, restriction one of the particles that can be occupy the number, occupy the one level GI, one level GI, one level GI, that is n indistinguishable particles in the GI indistinguishable particle levels. So let us find the degeneracy of levels function. The one particle state for unit is energy range. Energy range, that is three conditions. Three conditions. Boltzmann, Bose-Einstein statistics is understood the three conditions. The first condition is the particle are indistinguishable. Indistinguishable. Second one is each cell, each cell sublevel of eighth quantum state may contain 0 comma 1 comma 2 dash dash n identical particles. N identical particles. Same. The third one is the sum of the energy of all the particles, the different quantum groups taken the together constitute constitute the total energy of the system. Constitute the total energy of the system. Let us imagine a box divided into GI section, and the particles distributed among with the section. The total number of ways realizing the distribution Ni particle. Distribution Ni particle, that is Gi minus 1. That is Gi minus 1. Ni particles is equal to Gi minus 1. Next to comparison next to compartment of compartment of compartment of compartment of section is given by is given by this one is given by Gi into, that is not G1 and G1, that is equal to G1 into Ni minus Ni plus Gi minus 1. Gi minus 1. That is the distribution include the because of indistinguishability of particles ni factorial, the corresponding to permutation that corresponding to the same configuration with introduced by 1 by n factorial, 1 by n factorial. First one, that is the 1 by n factorial, 1 by n factorial. Second one is the distribution where the permutation of the cells amount with the do not produce the different state different states. The correction is 1 by gi factorial. First one is 1 by n factorial next to 1 by gi factorial. Ni factorial here 1 by gi factorial. That is the number of phase. That is the number of phase. Actually is equal to similarly G1 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 Ni plus Gi minus 1 by G1 minus by Gi factorial Ni factorial that is equal to this one, that is equal to this one. Okay, so you write this here is equal to this and here is equal to 12. So ni plus gi minus 1 by this gi minus 1 into n factorial ni factorial. Okay. So similarly the quantum states from the total number of ways in which the priority of probability the eigenstate probability the eigenstate the probability w of the system of the occurring with the specified distribution to the total number of eigenstate. Total number of eigenstate that is equal to which one? Omega is equal to that is here. So W is equal to capital phi into Ni factorial Ni plus Gi minus 1 by Ni factorial into Gi minus 1 factorial. This is also you write this factorial here. Gi factorial.
అర్థం కాకపోతే ఇది ఎట్లా వస్తుందో చెప్తారు కానీ నా క్లాసు నాకు విని పెట్టి
So here is the discussion. First have to the capital G is equal to first you write the value for the equation is equal to capital G is equal to this one you write this one. Have to simplify the equation Ni plus Gi minus 1 m minus 1 into factorial into by ni factorial by gi factorial minus 1 factorial into n2 plus n2 plus n2 plus it converted to the ni and ng value also converted to g1 g2 n1 n2 sigma 1 sigma 2, that is the convert that formula. So here this is n1 g1, they also g1, here is n1 that one. So into n2 plus g2 minus 1 by n2 factorial g2 factorial g2 minus 1 factorial. That is simplify the finally this one capital G is equal to capital pi of n ni minus ni plus gi minus 1 by this one ni factorial plus gi factorial gi minus 1 to factorial. This is numerator and denominator. Okay? That is the formula. This is you convert the this is total 5 here. Okay. So that is the formula. This is the postulate of the equal priority probability eigenstate value. Eigenstate value. The probability, the finally substitute the equal is the C is a constant. So here W is equal to eigenstate, the probability of W is equal to here. W equal to which one? It converted to this formula. Capital pi I capital pi I into total, you write this equation here. Is equal to n I plus gi minus 1 factorial by n I factorial plus into gi minus 1 factorial that is a into c is a constant, you multiply the c is a constant. So here that taken off, here first you take the Leiden value. So first you take Leiden value. Then value. So log of equation, that is the equation, log of equation 9.9. You are observed equation 9.9. The equation, the approximation method, the approximation we have the the delta large large W is equal to delta large W is equal to minus summation log ni by ni plus gi into delta ni. This is the multiply the log n value. Okay, so that is equation 9.10. The probability w to the maximize the w to the maximize the w2 can be delta log n of is equal to, this is delta log n of w is equal to 0. W is equal to 0. This equation yesterday I tell in this class. Omega is equal to w is equal to 0. The same time delta n is equal to summation delta ni is equal to 0. The next delta e is equal to summation delta ei delta is equal to delta e is equal to summation delta ni here multiplies sigma ni is equal to 0. The sigma is equal to 0. That is the problem. The Lagrange understands the multiply the way that Lagrangian equation, and this is the Lagrangian equation. That is the multiply the already which equation this is Lagrangian equation. Lagrangian polynomials ఈ mathematical physics లో వస్తుందండి క్వశ్చన్. That is the formula here. So summation that value summation I is equal to summation into log into ni by ni plus gi plus alpha plus beta sigma I into delta ni is equal to 0. Delta ni is equal to 0. This is a simplify the equations, both equations that. So that is Lagrangian equation, this formula. This is a substitute the formulas. Next, so delta ni here, delta ni value independent of each other value. That is log into ni by ni plus gi plus this value ni plus gi plus alpha plus beta sigma I is equal to 0. That is equal to, otherwise means delta ni is equal to sometime of is equal to 1. So that is a circuit there. So that is 1 is mean this is 1. So further the obtain the value ni by gi value and ni value individual the part of the different the equation. Individual part of the you write the equation from the ni by gi is equal to 1 by exponential of alpha plus beta sigma I minus 1 or ni is equal to gi exponential of alpha plus beta sigma I minus 1. That is called the Bose-Einstein distribution function. సేమ్ ఈ ఈక్వేషన్ మీకు ఎస్టర్డే క్లాస్ లో చెప్పినానమ్మా. ఇది 3 ఈక్వేషన్స్ ఉన్నాయి కదా, దట్ ఈస్ ఆల్సో మాక్స్వెల్ బోల్ట్జ్మాన్ పార్టిబుషన్ ఫంక్షన్. దిస్ ఆల్సో Bose-Einstein distribution of function. Another one, Fermi-Dirac statistical distribution function is also yesterday class is telling that one. So this is also same process, same formulas, that one. Okay, this question is very important. So next question, Fermi-Dirac statistics and distribution function. Fermi-Dirac distribution function. Fermi-Dirac statistics. Distribution function. This is also 10 marks అండి. బిఫోర్ క్వశ్చన్ ఈ క్వశ్చన్ లో కంపల్సరీ ఒక క్వశ్చన్ అయితే ఉంటుంది ఎగ్జామ్ లో. Distribution function. So this is also same process. So apply the indistinguishable of the particles having the half integral spin, are the particles of indistinguishable with the restriction that one particle will be occupied the single cell. That is a single cell. So distribution is the value, same energy levels, degeneracy, the occupation numbers. That is also occupation numbers. It's also same energy levels. Energy levels is equal to sigma 1 comma sigma 2 dash dash sigma 1 comma sigma 2 is equal to sigma k. Next one is degeneracy is equal to g1 comma g2 comma gk. Next to occupation number is equal to n1 comma n2 comma nk. That is I values. There is consider the k value is a function. K, the restriction of the one of the number, the particle occupy in the particular state. You observe that gi must be greater than or equal to ni. The observe that gi must be greater than equal to or equal to ni. The situation in the Fermi-Dirac statistics can now the particles in the indistinguishable, the cell may be contain 0 or 1 particle. Cell contain be 0 or 1 particle. The sum of the energies of the level the particles, the different quantum groups, constitute of total energy. The constitutive of total energy of the system, total energy of the system. The number of ways the Ni particles, Ni particles to Gi state, Ni particles to Gi states, that is Gi minus Gi minus 1, that is Gi into Gi minus 1, Gi minus 1 to dash dash, the Gi minus Ni, Gi minus Ni plus 1 is equal to, this is the is equal to Gi factorial by Gi factorial by Gi factorial by Gi factorial by this Gi minus Ni factorial, Ni factorial, okay? Ni factorial. The identical here, the identical nature of the indistinguishable of the particle written as the indistinguishable of the particle written as Gi Gi factorial. Here Gi factorial, this is Gi factorial by Ni factorial into Gi minus Ni factorial. That is, you write the formula. Okay, the formula. So factorial, the total number of eigenstates, the total number of the total number of eigenstate, the total number of states is given by is given by is given by G is equal to before equation and this one. G is equal to total capital pi Gi factorial this is Gi factorial by Ni factorial into Gi minus Ni factorial. Gi minus, this is also you write this one only. Gi factorial, this only. Okay, that is all. So is the total given, the total number of the eigenstate is given by G is equal to pi into Gi factorial by Ni factorial into Gi minus Ni factorial. That one. So that is the, you should substitute the probability. That is the next is the probability. First one is the total number of eigenstate. Second is the probability of W of specific state. The specific states, the proportional to the G. The specific state, the probability omega is, this is omega of the specific state, specific states is proportional to the G, proportional to G. That is omega is equal to capital pi. So this formula, capital pi capital Pi into gi factorial by n ni factorial into gi factorial, sorry, gi minus ni ni into gi into factorial into c. C is a constant. This is a c. Okay. So here, same. This is also you multiply the log n. Multiply the log. So log omega, applying the approximation and differentiating with the respect to differentiation with the respect to n1. We have n1 differentiating to n1. So that is the simplify the equation here. Summation i you multiply the log summation I log here gi by gi, sorry, you multiply the, this is which one, the n1 value, so ni, so you multiply the here ni by gi minus, here gi minus ni ni multiply the delta ni is equal to 0. Delta ni is equal to 0. That is the simplify the differentiating to ni formula. So that is summation I is equal to log of ni by gi minus ni into delta ni is equal to 0. So this is also you multiply the Lagrangian equation. The method of next step is you find out the Lagrangian formula. So same, the Lagrangian formula already you know that formula. Before your question is also I am telling that one. So summation next to the Lagrange method. The Lagrange method was summation delta ni is equal to 0. Delta ni is equal to 0 and delta e is equal to delta ni ei is equal to 0. Ei is equal to 0. So that is log omega 2. That is log omega 2 maximum value at that summation is equal to that of log ni by gi minus ni plus alpha plus beta ei sigma I epsilon I, this is the epsilon I is equal to 0. So this is the sigma ni are independent of another value in the sigma. This is a delta ni is independent 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 of the another value. So that is the value is delta n is equal to 0. Sorry, 1 now. So remaining value what? Remaining, yeah, this value only. So log ni by gi minus ni plus alpha plus beta epsilon I is equal to 0. Is equal to 0. This is also same simplification of the before question only. Okay. This is also same before question is the simplification. That is also same. Simplify the ni by gi value. Ni by gi value. Ni by gi is equal to what? Is multiply the exponential value. Exponential of alpha plus beta epsilon I plus 1 or ni is equal to ni is equal to ni is equal to ni is equal to we multiply this ni is equal to gi this one my cross multiplication this. Okay, you find out the only ni value, so here converted to gi by exponential of alpha plus beta epsilon I into plus 1 plus 1. So here ni is equal to here ni is equal to 1 by exponential ni is equal to gi plus 1. This equation here, this one is equal to the most probable the distribution of the Fermi-Dirac statistics. This is most probable of distribution in the Fermi-Dirac statistics. That is beta we get beta equal to 1 by beta equal to 1 by kt and alpha is equal to minus mu minus mu minus mu minus mu ni by kt, that is say beta value and alpha value, that is say. Okay, both values, that is say. So the three distribution functions is simplify the three distribution function. Sound ni by gi is equal to ni by gi is equal to this is three distribution function. Next is a three distribution function. Ni by gi is equal to 1 by exponential of alpha plus beta epsilon I. That is a three formulas there. That one exponential I, that is MB statistics. MB mean Maxwell Boltzmann statistics. Okay. Second one is Ni by Gi is equal to 1 by 1 by 1 by 1 by exponential of alpha plus beta epsilon I minus 1. minus 1. Second one is Ni by Gi, this is third one, is equal to 1 by exponential of alpha plus beta epsilon I plus 1. This is what? This is Bose Dirac statistics. This one is what? Fermi Dirac statistics. Fermi Dirac statistics. That is three formulas. This is a very competitive exam important formulas. This one. This is Maxwell-Boltzmann statistics. This is the formula. Ni by Gi is equal to 1 by exponential of alpha plus beta epsilon I. Here, both this one Both direct statistics, that one, that is 1 by exponential alpha plus beta epsilon I minus 1. This is minus 1 here. Okay, different. Next to Fermi-Dirac. Fermi-Dirac formula is same, 1 by exponential into alpha plus beta epsilon I plus 1. This is also you convert the formulas. How to convert the formulas? Here we find out the only for sometimes is asking is Ni values only. For example, this is the Ni by Gi formula. After that, for sometimes is asking Ni value. So Ni value we change here, cross multiplication this only. So here Ni value what here? Gi by exponential of alpha plus beta epsilon I. This is which one? Maxwell-Boltzmann statistics. Okay. Second one what? Ni is equal to same formula, only cross multiplication. This one is Ni. We find out the Ni value. Gi value is converted to here. So Gi by exponential of alpha plus beta epsilon I minus 1. And the third one is Ni is equal to Gi by exponential of alpha plus this one, alpha plus beta epsilon I plus 1. This is what? Fermi-Dirac. There is Fermi-Dirac. Sorry, this is Boson. BD. Second one. This is the first one. Second one. That is third one. Bose-Dirac distribution. Next one is Fermi-Dirac. That is the formulas. Three formulas. చాలా టైమ్స్ లో మీ కాంపిటేటివ్ ఎగ్జామ్ లో ఈ ఫార్ములాస్ అడిగాడండి. So that is the formulas. So you simplify the three equations there. So you are observe the Ni by Gi is very large comparison of one equation. The denominator by the exponential alpha plus beta epsilon I value, the Bose-Einstein and Fermi-Dirac functions. The neglected to the two statistics. That one is Maxwell-Boltzmann statistics. When the epsilon I is equal to mu, here epsilon I is equal to mu, Gi comma Ni comma Gi value is the value Bose-Einstein statistics. The infinity to the levels, epsilon I infinity to the levels, epsilon I less than mu. mu. That is the three equations. Less than mu, the negative, the meaningless of the Fermi Dirac statistics levels are the down to the lowest of the epsilon I decreases ni by gi is equal to 1. Ni by gi is equal to 1. Which one? That is epsilon I is equal to lowest value. Lowest value, that is the ni by gi is equal to 1. That is the first. That is the formula. So this is the simplification of the classical statistics and the mean expectation of the epsilon I minus epsilon I minus epsilon I minus epsilon I minus mu by kt mu by kt is the large number of the value at the above the figure. The n by n gi n by n is gi n by n gi n by n I gi, that is instead of instead of ni by gi ni by gi, that is the term of distribution function Maxwell Boltzmann statistics. That is the equation only. Okay, this is Fermi Dirac statistics and distribution function. Is a very important that one for this person. Next one, comparison of three statistics. ఈ క్వశ్చన్ త్రీ టైమ్స్ 5 మార్క్స్ క్వశ్చన్లు అడిగాడండి దిస్ క్వశ్చన్. కంపారిజన్ ఆఫ్ త్రీ స్టాటిస్టిక్స్, పేజ్ నెంబర్ 69. That is also important. 5 marks question sometimes is given that question. Comparison of three statistics. One is Maxwell Boltzmann, Einstein, Fermi Dirac. That is a comparison, that formulas and equations. What is the different? Okay. So this is three questions. Is one question is a compulsory PM your examination. First postulates of the quantum mechanics. That question 5 marks question compulsory question. Amma. Today class you have to discuss is the 15 marks question is a compulsory your exam. So next question. The postulates of quantum mechanics. Blood 3 అండి. Blood 3 principle of quantum mechanics లో పేజ్ నెంబర్ 73 75, పేజ్ నెంబర్ 75. This is also 5 marks question. Postulates of only 5 marks question. This is also important. Only 5 marks that. So The postulates of any theory of the say the fundamental statement. The fundamental statement. The fundamental statement is the cannot be explained in the terms of the other fundamental concept. Other fundamental concept. The basic postulates of quantum mechanics are basic basic postulates of quantum mechanics are that is five type of postulates. This is five type of postulates. Five type of postulates. Postulates one, the any state of dynamical state, any state of dynamical state, any state of dynamical state system of n degeneracy value. Sorry, the five type of postulates, five type of postulates. First is postulate value, postulate one, any state of dynamical system, any state of dynamical system of n degrees of freedom is describe the decrease the freedom is describe the complementary of wave function of wave function wave function wave function is j wave function is j such that j1 is equal to j into j into j into q1 comma q2 comma q3 dash dash qn comma t qn comma t qm comma t qm comma t is a function of coordinates and time. This is function of coordinates. T is the time. There is q1, q2, q3 dash dash qn is a function of coordinates. Where t is time. T is time. Okay. For a single particle in the wave function, a single particle, single particle wave function, single particle is a wave function is j is equal to j of r comma t. R comma t. R mean q1, q2, q3 dash dash qn value. T is the t. Time is t. Okay, that is the r value. So r is position here. This is r is position. T is the time. R is position. T is time value. So that is the important of properties. That is important of the properties of j. Important properties of j. That is a value. It is the three important properties. This one. This is the three important properties. First one is finite and a single value. It is finite and single value. Second one is the first derivative should be continuous. First derivative should be continuous. Third one is j star j dr is given. J star j dr given is probability of finding. If probability of finding the particle in the space with the position r, the space with the space with the position r and r and r plus dr. Here There is also J star. There is also J. That is value. J star into J value. So J star is a conjugate number and conjugate of J. J star is conjugate of J. Okay. That is the only postulate one. Postulate one. Okay. Next to postulate that is two. Postulate two. The postulate of two value is also the physical observable is associated with the linear Hermitian operator. Linear Hermitian operator. First postulate you are observed the wave function J is equal J into Q1 comma Q2 comma Q3 dash dash Qn of t. That is Q1 Q2 Q3 dash dash Qn is coordinate of the system. That is a t value. Next is the single particle. The single particles wave function is J of r comma t. Here r is position, t is the time. That is the space with the position of r and the r plus dr. That is the you write only postulate of one. That is enough. Next, second postulate of two, the Hermitian operator, the linear Hermitian operators. So that is quantum mechanical operator of for the total energy is the Hermitian operator linear linear Hermitian linear Hermitian operator is the mechanical the quantum mechanical operator the total energy or the or using total energy total energy of H capital H cap mean H mean Hermitian operator. Okay, H mean Hermitian OP Hermitian operator is equal to minus minus is equal to minus H square by 2m delta square plus v. This is time independent formula. This is time independent formula. Okay. Hermitian operator is equal H is equal to minus H square by 2m delta square plus v. That is time independent formula. So this is equal to also similarly there is also a Hermitian operator S cap of P is equal to also I H dot dou by dou t. So dou by dou t. This is time time dependent time dependent time dependent formula. Okay. So this is only simplify the postulates of one this coordinate system. Postulate of two the Hermitian operator is the total energy formula. This one is a formula. This is the Hermitian operator using the total energy depending on the independent and dependent time independent and dependent formulas. So that is Hermitian operator is equal to minus h square by 2m delta square plus v. That is the time independent time independent formula. H is equal to I H dot by I H dot into dou by dou t. That is a time dependent formula. That is enough. So that is the postulate of two. The operator alpha operating on the two functions. That is a two function here. This is also two functions. One is J1 and J2. J1 and J2. J1 and J2. The Hermitian operator is the classical expression of observable is the written as Cartesian coordinates. That is the Cartesian coordinates. Cartesian coordinates q value, momenta p and t. Cartesian coordinates value q, comma p, comma p. That is the value here. Q, comma p, comma t. So here p is q is Cartesian coordinates. Q value is Cartesian coordinates. P is momenta. T is time. That is the postulate of two value. Next, third one is the state function. Postulates three value. That is postulate three value. The state function of J. This is the state function. The state function. The state function. State function. J of q comma t. J of q comma t is the equation. The equation. The equation. Hermitian operator is equal to J of Hermitian operator into this J of q comma t q comma t q comma t is equal to I h start dou by dou t. I h start dou by dou t into J of q comma t. So here I h start by dou t value which formula? Time dependent formula. I h start dou by dou t into J of q comma t. That is the value. So this formula depending on the time dependent formula. Okay. So that is the Hermitian operator of the system. The postulates of the system. The postulate of the statement of time dependent. Postulate of the statement of time dependent Schrodinger equation. That is the time dependent Schrodinger equation. Next, fourth one is postulate fourth statement. Postulates is 4. Postulate is a 4. Postulate is a 4. So this is also identical system. For the set of identical system, the state of J of q comma t. The state of J of q comma t. The state function is eigenfunction. State function is an eigenfunction of the operator corresponding to the observable. Then the successive the measurement will be given the same value of observable a into Jn of q comma t Jn of q comma t is equal to an an is equal to an j of n q comma t That is the formula of postulate of 4. That n is the here n value n is the eigen value of equation. Eigenvalue of equation. Eigenvalue of equation. So next to postulate 5. Postulates 5. The average value of observable A. The average value of observable is equal to A. Is equal to A through A. The corresponding to the operator. The corresponding to the corresponding to the operator. The corresponding to the operator alpha. Alpha. For the system, describe the wave function. The system. The system. The system. The system. Describe the wave function. Wave function is equal to z. Wave function is equal to function is z. So here this one is a value. The average value of the observable is a. That is equal to small s of is equal to a is equal to integral of j star j star j star j star j star alpha 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 j alpha j alpha j d star d star alpha j star alpha j d star d star d star by integral of j star j into d star j is equal to d star is the bracket of j is is called the expectation value is called the expectation the value. This is postulate of 5. Okay, this is the postulate of 5. We compulsory question. This is also 5 marks question compulsory. Okay, postulates of quantum mechanics. This one first starting question. First starting చెప్పాను కదా ఆ క్వశ్చన్ ఈ క్వశ్చన్ 2 క్వశ్చన్ కంపల్సరీ 1 క్వశ్చన్ యువర్ ఎగ్జామినేషన్ ఈ ఎగ్జామ్ లో కంపల్సరీ ఆ ఫస్ట్ చెప్పిన క్వశ్చన్ ఈ క్వశ్చన్ లో కంపల్సరీ ఈ రెండిట్లో ఏదైనా ఒకటి కంపల్సరీ ఉంటుంది ఎగ్జామ్ లో ప్లస్ ఆ 3 లాంగ్ క్వశ్చన్ చెప్పాను కదా 3 లాంగ్ క్వశ్చన్ లో 1 లాంగ్ క్వశ్చన్ కంపల్సరీ ఉంటుంది 15 మార్క్స్ క్వశ్చన్ కంపల్సరీ మీ పేపర్ లో ఉంటుంది ఎగ్జామ్ లో ఓకే ఓకే టైమ్ ఈజ్ ఓవర్ థ్యాంక్ యూ అండి ఎనీబడి థ్యాంక్ యూ
థ్యాంక్ యూ సార్
ఓకే
Thank you, sir.
ఓకే అండి వెల్కమ్